Hey there! For today's video we're going to do something a little bit different. This is an amplifier, stereo amplifier out of a car, and I don't typically work on audio equipment, so this is kind of outside of what I know, but this belongs to a friend. He said it wasn't working properly. He asked me to take a look at it, so that's what I'm going to do. Specifically, this is a Kenwood KAC-6202. And the reported problem is one of the two channels has a problem, either the left or the right, I don't know. And I don't know if it's cut out or if it doesn't work, if it has static on the channel. One of the two channels has a problem. Now, initially when I got this, I tried to hook it up to my bench power supply and feed in an audio signal to see if I could reproduce the problem. And car stereos, amplifiers, these are outside of my norm, what I work with. I don't know how to get it to power up. I couldn't actually get it to turn on. So since I can't reproduce the problem, I'm basically just going to have to kind of take it apart, do some preventative maintenance, I guess you could say, on it, and just poke around and see if I get lucky and find what the problem is, but I may not actually know. But anyway, I thought it might be interesting to see how I go through and actually try and repair this one. So first, let's turn it over and take it apart. With the back off, this is what it looks like. Now, since I can't actually get it to power up, my plan of attack here is kind of threefold. So first off, you'll see a lot of capacitors on the board, and I'll go through and I'm going to check each one with the Esr meter just to make sure that we don't have a bad capacitor. Then the second thing I'm going to do, mounted to the heatsink itself, or basically the shell, which is the heatsink, both sides are a line of transistors, and one's going to be for the left, one's going to be for the right, and they're matching. So like if there's a, C4468, then over here is another C4468. So they're going to be matching channels here, and what I'm going to do is use my multimeter to check each and see if they match up. If I get different readings from one versus the other, then chances are I know, one of those two is bad. And I'm hoping this will, if that's where the problem is, it'll let me know where it is. And then the final thing I'm going to do is there's a couple of potentiometers on the board here, and I'll spray those with contact cleaner just in case it's a simple matter of dirty contacts. So I'm going to start off with measuring the various transistors and amplifiers mounted to the board here. And I should say, now when I'm testing these, I don't know the official way to test this. What I'm going to do is I'm just going to put my multimeter into resistance and or diode mode and check, like pin 1 to pin 2, and compare that to the same component on the other side, pin 1 to pin 2, and see if I get a similar reading. And just do that for all pin combinations on all the devices here, and look for consistencies. And if I have something that's different, that's probably an indication of a problem. But if they check out the same, then it's probably good to go. So let's go ahead and get the multimeter out and give that a try. So I wanted to show how I'm testing the transistors and amplifiers in this device. So I've got my multimeter here, and it's currently set on the diode range. And then I've got my two probes, and this is one of the devices I'm going to look at up here. So basically I'll start off with the black probe on pin number 1, and then touch pin number 2, and so I get 0.56 volts, and then go over pin 0.56. So I'll write those two numbers down, and then I'll move the probe to the middle pin and touch the first and third. So 1 point something, and then it quickly dropped to 0, which is expected. 1.4. It'll climb, and about when it gets to 2, it'll drop to 0. And this is, it's charging, and then it's going to close. So that's actually expected behavior. And drop. And then I'll move the pin to the third lead and test the first two. 0.8. and 0.9. So basically for every combination, I'll write them down on a piece of paper, then I'll turn the unit around and test the matching component on the other side and see if I get the same numbers, same behavior. And when I do that, I can't find any amplifiers or transistors that behave differently on one channel versus the other. So, you know, I'm not an expert, but it looks to me like the amplifiers and transistors in here are fine. That's not the problem. So we'll have to look elsewhere, and next step we'll look at these capacitors. Well, as far as testing capacitors go, to do this properly you need one of these. This is an Esr meter, and this is definitely a specialized tool. Not many people are going to have it, but if you do have it, it makes testing capacitors pretty easy. You just touch the probes onto either lead and you can check it, and then you have to know whether or not a number is good. Basically, as a general rule, the larger the capacitor, the smaller the value should be. So a small capacitor can have a larger number and still be good. A larger capacitor, the number should be small for it to still be good. Now, testing it's pretty easy. For example, let's turn it over here and let's zoom in on a couple of points here. So right here are 4 points, which is the back of 2 capacitors. And so if I bring the meter in, so I can touch it to those points, and I get 1.1. Now usually if the capacitor were larger, a value of 1 or more indicates it's bad. But these are small capacitors, so a value of 1 doesn't scare me. If that were like 10, I would say replace it, it's probably bad. But given the size, that's a good value. So yeah, I've checked every capacitor on here, and I do not see a problem with the capacitors, so we'll move on to the next thing. Well, for the next thing, I've got some potentiometers here, basically some knobs and dials and switches, and I'm going to spray some contact cleaner in there. And we've all experienced it. You've got that stereo at home, you turn the volume up or down and it crackles as you go, and that's because the contacts inside here get dirty. And this is how you can fix that. You spray that in there and then you operate it. You turn it back and forth to kind of clean the contacts, and that will clean it if that's the problem. Now unfortunately I won't know if this actually fixes it. We'll just have to plug it back in and try it. But yeah, I'm going to spray that in there and we'll give it a go. And I've never done this before, so it sure comes out forcefully. Okay, and then just kind of operate each switch and dial. Well, there we go. So we're done with that step, and I think I've got one more thing I'm going to try on this. So we'll try that next. So the last thing I'm going to do on this board is flip it over and basically look for any cracked solder joints which could indicate intermittent contact. And I'm basically going to do 2 different areas. First off, anything that interacts with the outside. So, you know, here's some plugs here and you push on them, and that could cause stress on the board here where it connects. So anywhere there's a connector, I'll look at the board. And then the second one, all these components around the edge that were attached to the heatsink. The thermal shock of heating up, cooling down over time could crack the joints. Now, I've kind of looked at it a little bit. I'm going to do some more. I haven't immediately noticed anything. You know, some of these items may actually go through and just touch up the solder just in case I can't see a problem, but this will be kind of the last thing, and then we'll go ahead and put it back together. Well, I think I reached the end of this project. I didn't find any cracked solder joints. I did go through and touch up the solder on a couple of these components, but all in all, I'm not quite sure if this unit is actually repaired. In fact, if I had to guess, I'd say it's probably not. I wasn't able to find if it was a transistor or a capacitor. I would have found it for sure and been able to replace it. But since those all tested fine, unless it was the contact cleaner or a cracked solder joint that I couldn't notice, those are the two things that I did that I won't know if I repaired it until it's actually plugged in and tested. So, and since I can't test this, I won't know. So I'm just going to have to return this to my friend and let him tell me if it's working or not. But anyway, I hope you found this video interesting to see how I personally would take apart an amplifier and test it. Again, I'm not an audio expert, but yeah, it was kind of a fun project. Thanks for watching.